All right, guys, welcome to our new unit, Unit 5. We're going to talk about radical functions. Radical is just another way of talking about things like square roots. And we'll see that there's other kinds of roots as well. And when you put all those roots together, we call those radicals. So today, basically, we're just going to be introducing you to the concept. So here we go. The first thing we're going to look at is we want you guys to be able to find the nth root of a given number. Now, n means just any root. So you guys are used to finding square roots, but what about things like a fifth root, or maybe a third root, or a fourth root? So we're going to learn how to find nth roots today. And also we're going to learn how to evaluate terms that have fraction exponents. And that may seem random, like why are we talking about fraction exponents and roots at the same time? But actually they're actually the same exact thing. They just look different. So that's why we're talking about both of them in the same day. All right, so let's go ahead and begin here. Let's talk about nth roots. Now, as you guys know, a square root like this one, square root of 8, basically what that does is we take the number 8 and we break it apart into whatever numbers multiply together to make 8. And you keep doing that until you end up with all prime numbers. So when you break 8 up, basically you end up with 2 times 2 times 2. And with the square root, what we could do, but we usually don't, okay, but you could technically put a little 2 out here. And what that 2 represents is we're looking for groups of two things that are the same that are underneath of the square root. So in this case, I do have two numbers that are the same. I've got two 2's. And for every group, you can write that number outside the radical once and then cross off the group, and then whatever's left, you just leave it on the inside. So that's how we do square roots. But when we're talking about nth roots, like this one here, a different root, this is a third root. So in this case, whenever we take the time to break down our 8, we're looking for a third root. And what that means is I'm looking for 3 numbers that are multiplied by each other that are the same. And so we have that here. So now instead of looking for 2 numbers that multiply to make the same thing, we're looking for 3 numbers that multiply together. So for every group of 3, I can write a 2 on the outside and cross it off. Now another way you could think about this is you could think of this as a question. Let me clear this up a little bit. You could think of this as what number multiplied by itself 3 times makes 8. Okay, so you could think of it like that. But I think a more effective way of going through all this is just to go ahead and break it apart like we did with square roots. And since there's a 3 here, we're looking for groups of 3 identical numbers. And if you have a group of 3 identical numbers, you write it once on the outside, cross off the group. And in this case, since there's nothing else left under the square root, the answer is just 2. And we could check our answer by going back to this question. What number multiplied by itself 3 times makes 8? Well, sure enough, 2 times 2 times 2 does equal 8. And so that's what a third root is. Okay. Now let's go back to square roots here for a second. When we were talking about square roots, we had an interesting thing happen. We saw that you can't have a negative on the square root. And the reason for that is because when you're doing a square root, you're looking for a number that is being multiplied by itself twice to make this number. And here's the problem when you have a negative. You can't ever multiply a number by itself and get a negative out of it. Because if you're multiplying a number by itself, then either you're doing a positive times a positive, which is positive, or you're doing a negative times a negative, which is also positive. So it's impossible to multiply a number by itself twice to get a negative number. And so the way that we dealt with that, in case you guys forgot, was we created a new kind of number called an imaginary number where you take the negative out, put an I in the front, and that I represents the fact that, okay, well, we're dealing with an imaginary number, okay? But now that we've taken the negative out and put an I out here in the front, now we can just kind of break the 8 down like we're used to. So if I were to break down 8 like I have already, you get 3 2's. And since this is a square root, we're looking for groups of 2 numbers that are identical being multiplied together. For every group, you can take that number out, cross off the group. And you basically get the same answer that we had in number 2 there, but this time it has an I because it was negative. But let's go ahead and take a look at this one. Now, this one, as you guys remember, we can rewrite this as a question. We could say, what number multiplied by itself 3 times makes negative 8? Well, unlike number 3 up here, there was no such thing that you could multiply by itself twice to get negative 8. Actually, there is a number that you can multiply by itself 3 times to get negative 8, and the answer is negative 2. Just check it out. Negative 2 times negative 2 times negative 2 actually makes negative 8. And so this one is not an imaginary answer. This one actually gives a real answer. So the answer is negative 2. So let's compare and contrast these two things. Okay. So whenever you have an even number here, like 2, and a negative on the inside, what you're going to do is you're going to cross the negative off of the inside, and you're going to put an I on the outside. But if you have an odd root with a negative on the inside, you're going to cross the negative off, but you're not going to put a negative, you're not going to put an I outside, you're just going to put a minus outside. Okay? So they're the same in that we're just going to take the negative out of both of them. But for problems where you have an odd root, you actually just put a negative outside. But for problems where you have an even root, you actually put an I on the outside. Or I guess we should say a square root to be more specific. Okay. All right. So that being said, we've learned a new fact, and it's probably a good idea to write that fact down. So let's go ahead and do that. And I would encourage you guys to do the same thing here, is write this down on your notes. Okay. Okay, so if we have a negative number underneath the radical sign, and the root that we're working with is a second root, in other words, a square root, then we end up with an imaginary number. If the root is odd, then we just get a negative real number as a result. Okay. Now you guys might be wondering, well, what if there's a fourth root with a negative underneath? Well, that's still going to be imaginary, but I'm not going to give any problems like that. I might give you like an extra credit question to think about it because it's a little bit complicated to figure out what it is. But for our class's purposes, all you really need to know is what happens if there's a negative under a square root. So I'm just going to leave that as a 2. But technically, all even roots are going to have negative, or are going to have imaginary answers, but they're a little bit different than square roots in the way that they're worked out. But anyway, let's go ahead and move on to number 5 here. So on number 5, as you guys can see, we're dealing with 16. And we also have a fourth root. Okay, and so that means that once I break this thing up, which let me go ahead and do that first. Once we break that up, we're looking for a number that is being multiplied by itself 4 times. And in this case, that's what we happen to have. So I've got 4 2's. So since I've got one, for every group, I could put that number outside of the radical once and then cross off the group. And so this one's answer is simply 2. Now every once in a while, you'll come across one that just can't be simplified, like number 6 here. on number 6, it's asking us to find the 5th root. And we've already broken down 16, and we saw that that was 4 2's. You can't break that down any more than that, right? Well, since I'm looking for a 5th root, I'm looking for a number that's being multiplied by itself 5 times, and we don't have that. So, unfortunately, I can't simplify this at all. And when that happens, you guys, you just leave it just as it is, because that's as simple as it gets. Okay? So that's what a root is. All right, so now this number underneath of the square root, or the radical there, is what we call the radicand. This number here is, you could either call it the root, or you can call it the index. I've heard some people call it an index. It doesn't really matter, but there it is. So that there's some vocabulary for you there. Now, we also kind of looked at this stuff here. So if x is positive, in other words, if you have a positive radicand and n is even, then technically you're going to get a real answer. So I'm going to put R here for real. Now on your guys' notes, maybe you actually we'll just write the word out just so you actually get a real answer whenever you have a positive number underneath of the radicand and you have an even root, even index, okay? But something I didn't demonstrate on the last slide, but I'll explain in a minute here, is you actually get two answers, a positive and a negative one. So for instance, if I gave you guys this, and I asked you guys to find me what's the square root of 4, well, technically the answer is 2, right? What number multiplies by itself to make 4? Well, you could say technically 2, right? But couldn't you also say negative 2? Because negative 2 multiplied by itself also gives 4. So whenever you have an even root and a positive number here, you technically get 2 real answers. One of them's positive and one of them's negative. Okay? Now, we also saw what happens, though, when you have an even root and there's a negative underneath. When that happens, we're going to take the negative out, and we're going to put it on the outside as an I, and we get an imaginary answer, right? But technically, once again, you could get 2 answers, okay? So the answer to this one could be positive or negative 2i, okay? Why? Because the square root of 4 is 2, and then we have the I. But technically, the square root of 4 could be positive or negative 2, right? So it's positive or negative 2i. Now, when it comes to having an odd root, though, as we talked about on the last slide, and if you have a positive number under the root, you're just going to get one real positive answer. You don't get 2. You just get 1. In other words, if I ask you guys what's the cube root of 8, there's only one answer for that, and the answer is 2. Negative 2 won't work, because negative 2 would actually make a negative 8. And that's why in this last slide over here, if we have a negative radicand and an odd root, you're going to get one real negative number. And so this is a nice little chart just to kind of help you guys understand how things will work out. So let me give you one last thing just to kind of ponder upon here. Erase my paper. So let's say, for instance, that I had following thing. Let's say I had oops, that's too big. Let's say that I had the number 5 here, and we had a negative 81 right here. Okay? Well, I've got a odd root, and I've got a negative radicand. And therefore, I know that I'm going to end up with one negative real answer. Okay? Let's do another one. Let's say I had a 6th root here, and there was like a, I don't know, 64. In that case, I have an even root, and a positive radicand. In that case, I know that I'm going to technically get a positive and a negative real answer. Okay, so that's how roots work and the types of answers you can get for each one. So let's go ahead and put this to work for us and actually do the problem solve. So in this case, notice I have a odd, and underneath I've got a positive. So I've got an odd root and a positive radicand. When that happens, that means we should expect to have one real and positive answer. So a one real positive answer. So what we're going to do now is we're going to go ahead and just break this thing apart. 256 and k to the fourth. All right, well, first of all, 256, I'm pretty sure that is, gosh, that's a pretty big number. Let's just do 2, just to be safe. I think it's 16 times 16, but I'm just going to do 2 just to be safe. So I know 2 goes in there. 1, 2, 8. Then we can break that again by 2. That's going to be 64. Yeah, okay, we're getting there. So 64 is 8 times 8. And we already know from multiple problems we've done today that 8 is basically just 3 2's, right? And so basically, what do I have here then? I've got 1, 2, 3, 4, 5, 6, 7, 8 2's underneath of this square root. I'm not a square root, I'm sorry, it's a fifth root, my bad. So I've got 8 2's, and I have 4 k's. And we're looking for a fifth root. Okay, so that means I'm looking for groups of 5 numbers that are identical. Well, I've got enough 2's. 1, 2, 3, 4, 5. There's 5 2's right there. So for that group, I can cross that off and put a 2 on the outside. But that's it. I don't have any more groups of 5, right? The k's got close, but they weren't quite there. So my answer is 2, fifth root of 2 times 2 times 2 is 8, is left on the inside, and 4 k's makes k to the fourth. And that's going to be as simplified as it gets. Okay? And notice we should have one real positive answer, and that's what this is. I've got a positive, there's no negatives, and I've only got one answer. It's not like I've got a plus and a minus, right? There's our solution. Let's go ahead and take a look at the next one here on number 2. So this time I have an even root and a positive number, and when that happens, we should expect to have a positive and a negative real answer, okay? So let's go ahead and get to work here. So first of all, we have the 648. I'm pretty sure 6 goes in there. 6 goes into 6 once and 48 8 times. So we have 6 goes into there 108 times. 6 is 2 times 3. And 108, isn't that 12 times 9, I believe? 12 is 6 times 2, and 9 is 3 times 3, and 6 is 2 times 3. All right, so we broke it down all the way. And I find, you guys, that this is a place where a lot of students get stuck just because we're always not so hot on our times tables. So a good way to make sure you're right is just look at all of the ends of your branches here and take all those numbers and on a calculator multiply them together really quick. 2 times 3 times 2 times 3 times 2 times 3 times 3. If you multiply all those together, you should get 648. If you don't, then you did something wrong. You need to go back and double check your factoring a little bit. Okay, so I've got fourth root, and how many 2's do I have? I'm just going to put all my 2's together. I have 1, 2, 3. I've got 3 2's, and how many 3's do I have? 1, 2, 3, 4 3's. So 1, 2, 3, 4. And then also we have r to the fourth. Now that means I've got r being multiplied by itself 4 times as well. And remember, we're looking for groups of 4 numbers that are identical. So there's 4 3's, and there's 4 r's. So I could take a 3 out and cross off the group of 4 3's, and I can take an r out and cross off the group of 4 r's. I do not have enough 2's to take out. So now on the outside, I've got a 3 and an r, and on the inside, I've got 3 2's, which I'm just going to put back together with an 8. But don't forget, we should have a positive and a negative. So all we have to do is put a plus and a minus here. So the answer is plus and minus 3r, fourth root of 8. Okay? So the first thing I do is I just kind of ask myself, how many answers should I get and what should they look like? Should I have 2 reals, 2 imaginaries, or 1 real positive number or 1 real negative number? It just depends on the roots and the radicand, and the way you can answer that is by looking back at this last slide that we had. After you do that, you just go ahead and break it down, take out the pairs, and then make sure your answer fits what you predicted it should have, and you're good to go. So let's go ahead and give it a try here. Student practice number 1. Go ahead and work on these 3 problems. Now, number 3 is an extra credit problem, and I'm going to tell you what the answer is not, okay? The answer is not negative 2i, and it's not positive 2i. It's not negative 2, and it's not positive 2. None of these are the answers. So I'll let you guys ponder it, though. And if you want, you can just email me what you believe the correct answer to be. If you get it right, I will give you a bonus 5 points on your homework. But just so you know, none of these are the correct answers, so don't do any of those. But other than that, just save that for later. For now, I want you guys to pause the video and make sure that you guys can do these 2 problems, which are the basic idea. Okay? All right, so for number 1, we had an odd root here with a negative on the inside. Now, when there's a negative on the inside, what did we say to do? You cross the negative off, and since it's an odd root, we put a negative in the front. If it was a square root, we would put an I, okay? But since it's an odd root, we just put a negative. After that, you just have 54r to the 4th power, so you break down your 54, and you get 3 times 3 times 3 times 2 times r times r times r. And then we could take out a 3 and an r, and the 2 has to stay inside, and then make sure that negative's there. So we should have 1 negative real answer. Now in number 2, we have an even root and a positive number, which means you should end up with a positive and a negative answer. So all we do is, for this one, there's no negatives to take out. We just start by breaking it down. It's just 5 times 2 times 2 times 2 times 2 times x, which means I'm able to take a 2 out, and I'm left with 5x squared on the inside, and don't forget your minus. Now, just so you guys know, the way that this thing works, you can't just cross this off and put an I in the front. You do that for square roots, but not for 4th roots, okay? So here's a better way of thinking about it. Whenever you're done figuring out your answer, whatever it is, you're asking yourself what number multiplied by itself 4 times will give you negative 16. So try to think about it from that angle. What number multiplied by itself 4 times can give you a negative 16? All right, a little tricky. If you can get it, awesome. If not, that's okay. Just email me though if you get it, and I'll hook you up with some extra credit points. So now we're going to talk about fraction exponents here. So you guys know what 8 to the 1st power is. You know what 8 to the 2nd power is. But what is 8 to the 1/3 power? How does that work? Well, let's just think about it a little bit. So we know that it's going to probably equal something, right? Question mark there. We just don't know what it is. Now, there's an interesting little property for exponents, and it kind of works like this. So if you have something being raised to a power, and you raise that to another power, then basically you just multiply those 2 exponents together. So the n would be multiplied times the n. Now the reason that that's helpful to us is because we have a fraction, and we don't like fractions, right? And what have we done with fractions anytime we don't like them? Well, we've always raised them, or we've always multiplied them by the bottom number. Now the way that I can multiply that exponent by 3 is if I raised my whole expression here to the 3rd power. Okay, but since this is an equation now, I need to raise this side by the 3rd power also. So now if you do 3 times a 3rd, the 3's cancel, and you're basically left with just a 1, right? And that's 8 to the 1st power. Now 8 to the 1st power is pretty simple. It's just going to be 8, right? So, and so now we've rewritten this in a different way. We started off with 8 to the 1/3 power equals something, but now it looks like this. Something raised to the third power equals 8. But those are identical expressions, they're just written differently. So in other words, what number to the third power, or you could also say what number multiplied by itself 3 times makes 8? Well, we saw that earlier today, right? And the answer is 2. So another way you could think about this is you could say, oh, well, that number must be the cube root of 8. Okay, so instead of doing all this work every time, what we're going to do is we're always going to jump straight from this step now to this step. All right, let's go ahead and take a look at another example really quick, though, before we get too comfortable. Let's say we had 8 to the 2/3 power. Well, for this one, I could rewrite it like this, can't I? Kind of using the same rule. I'm just kind of working backwards. So I'm going to take the 2 out and put it out there as another power, because if we multiply 2 times a third, we get 2/3, right? So I just rewrote it so it looks a little bit differently. And we've already solved this problem, right? That's basically just going to be the cube root of 8. Okay? So if you wanted to simplify this more, you could find the cube root of 8, which is 2, and then you would square it, which is 4. So now we kind of have a little bit of a process to work with. We could change it from being a fraction to being a root expression. Okay, and so here's our conclusion that we're going to get to be able to get an answer. These two expressions are identical. So if you have a being raised to the fraction power of t over b, you can rewrite this as an equivalent expression where you have b in the place where the root would be and t in the place of where the exponent would be. Now there's another way you can write this, and sometimes it's easy to write it one way and sometimes it's easy to write it another. But another way that you could write it is like this. You could put the t inside the root with the a as well. So you can either have the t outside the root or you could have it inside. Either way, you're going to end up with the same answer. Okay. Now, for our purposes, I think I'm just going to be sticking with this one for the most part. This one here in the middle works really well when you have perfect roots. A perfect root is where after you break it down and you take out everything you can, there's nothing else left underneath the radical. In other words, everything comes out of the radical. And this one here works really well for that. And that's pretty much the only kinds I'm going to be giving you guys. However, this one, it can be useful too. Now the difference is here, for this one in the middle, you do the root first and then you do the power after that. For this one here, since the t is under the radical, you would do the power first and then you would take the root. So the reason why this one's a little bit less attractive is because since you start by raising this thing to a power, you end up with a big number, okay? But the reason why that's helpful is because if you don't have a perfect root, sometimes by raising it to a power, you get more numbers, so you can actually take more stuff out than it would look before you took the root. So, but anyway, like I said, we're going to be sticking pretty much with this middle one. But the other one works just as fine. So let's go ahead and jump in and we'll do a problem here and I'll show you what I mean. So the first thing we're going to do with each of these problems, we're going to rewrite them. We're going to change them from being in exponential form into radical form. And then we're going to use what we've learned about simplifying radicals to get the actual answer. So for number 1, we're starting off with 32 to the 1/5 power. Now if I were to rewrite that as a radical, the denominator of the power is my root. The 32 is going to be my radicand. We're going to put that in parentheses. And then the numerator of my power is going to just go out here on the outside. So now what we're going to do is we're going to take the root first. So what's the 5th root of 32? Well, if you were to break down 32, you would end up with 5 2's. And that's not a surprise because I told you I was going to give you some perfect roots. In this case, we have exactly 5 2's, and that's how many we need to take one out. So for every group of 5, I can put one outside the radical and cross this off. And now since there's nothing else under the radical, we don't need the radical anymore, and all we have is this 2 on the outside. But don't forget, we still have parentheses with the power of 1 out here, and then 2 to the first power is 2. Okay? So that's it. So step 1 is to rewrite it. Step 2 is to simplify it. So rewrite and simplify. All right? Let's go ahead and do number 2. So in this case, I would encourage you guys to think for a minute as I ask you some questions. What would you put right here? Hopefully you thought of 4. It's the denominator of the fraction that's in the power. What would go in here? That would be the 81. And then finally, there's only one other number, and it goes out here, and that would be the 5, the numerator of the power. So now, the next thing we need to do is simplify this, the 4th root of 81. We're going to break that down. And it turns out that if you broke down 81 correctly, you would find that it's 3 times 3 times 3 times 3. Since we're looking for groups of 4 numbers that are identical, we have that. So I could take a 3 out, drop group, and now I'm left with 3 to the 5th power. Now, 3 to the 5th power, that's going to be, you have to do that on a calculator. On your calculator, you're going to type in the number 3, and you're going to find a button that either looks like this or something like this. Power button. So it's going to be 3, and you're going to push one of those 2 buttons, and then 5, and then of course you're going to push the equal button, and you should get 243. Or you can just work it out mentally and just actually do 3 multiplied by itself 5 times to get the answer. But the answer would be 243. Okay? Let's do one more like that, and then I'm going to let you guys practice a couple. I'm not going to do 4, 5, and 6 just yet because they have an extra little twist to them. So, fill in your 3 blanks here. What would that be? It would be 3, 16, and 2. Okay? Now, we're going to find the 3rd root of 16. Now, this one's not a perfect square root. So I guess I lied. I'm not only going to give you some perfect roots. Oh, well. Anyway, what's the 3rd root of this? Well, we have 4 2's, so I could take a group of, for this group of 3, I can take a 2 out, right? So there's that. Get rid of the group. And so now I'm left with 2, 3rd root of 2. And then we're going to square it. Now, when you square this, you're going to square the outside number and you're going to square the inside number. So it's going to be 2 squared times the cube root of 2 squared. And that's 4 when you do 2 squared, and 4. Now, here's the thing. If you're going to square this inside number, it just got bigger, right? And now the question is, since it got bigger, will you be able to take more out? Well, if you broke down 4, you're just going to get 2 times 2, right? So we still don't have a group of 3. So we're just going to leave it like this because there's no more things for me to take out of there. But just be aware that if you ever have the situation where you don't have a perfect root, if you do it this way, after you square the inside, you might have to break down the root again and take out more because by squaring it, you put more numbers inside. Now, just for the heck of it, I want to show you guys an alternative way to approach this problem. And that's the other way I told you. So this is a way that you can use it whenever you are not having a perfect square root. So we know that 16, the cube root of 16 is not a perfect number. So instead, I'm just going to put a 2 in here. Okay. So instead of putting the 2 on the outside like I did last time, I put it on the inside. Now, since I have a 2 on the inside, I've got 2 16s being multiplied by each other. And each of those 16s are 4 2's. So I basically end up with 8 2's. So I could take out a group of 3 here, and I could take out a group of 3 here. So I could take out 2 twice. So 2 times 2 on the outside is 4, and 2 times 2 on the inside is 4. We get the same answer. It's just that it's a little bit more work. So when you put the 2 on the inside, that means you're going to have 2 of those numbers, and you have to break all of them down. So you get a lot more inside to take out. But it might help alleviate the confusion that the last problem had, where after you square it, you might have to break it down again. So that's why sometimes it's good to put the 2 inside as opposed to outside. When you have a perfect square root, it's just better to put it outside. But when you have a non-perfect square root, like the cube root of 16, it might be good to put it on the inside just so you don't have to make an extra step for yourself. But either way, it doesn't matter which one you choose. You should get the right answer if you follow it correctly. So I'm going to have you guys do numbers 1 and 2 here. So go ahead and pause the video here. See if you guys can do numbers 1 and 2. When I pause the video, you'll see the solutions. All right, so let's go ahead and take a look at this. So number 1, this is how you would rewrite number 1. Number 2, when you break down the step 2, when you break down your 16, you get 2, 2, 2, 2. We're looking for the 4th root of 2. I do have a group of 4, so I could take a 2 out. And there's nothing left inside, so the 2's out here. We have our first power, 2 to the first power is 2. Now, I forgot to do something on my example problems that maybe some of you guys noticed. I forgot to do that process where we think about our answers before we begin. I have an even root with a positive radicand, which means technically after you take the 4th root of 16, we should have gotten 2 answers, a positive and a negative. So when you raise a positive 2 to the first power, you get a positive 2. And when you raise a negative 2 to the first power, you get a negative 2. So technically this one should have had a positive 2 and a negative 2 as an answer. 2 answers. And I apologize, I forgot to do that on my examples. Let's take a look at the next one here. Now for this next one, we have 32 being raised to the 2/5 power. Okay, so we're going to be finding the 5th root of 32, and then we're going to square it. The 5th root of 32, as we saw before, is 2. 2, 2, 2, 2, 2. And the 5th root is basically we have a group of 5 2's. Take out your 2 and drop the group out, and then you're left with 2 to square. Now remember, whenever you have an odd root and a positive number, you only get one real answer, so it's just positive 2. Positive 2 to the 2nd power is 4. Okay? So we end up with only one answer here. It's going to be 4. All right, so that's the basic idea there. Let's go ahead and back up a little bit. We're going to do some other problems now. All right, so how do we handle negative exponents? All right, well, there's a little rule in math where if you have a to the power of negative n, you could rewrite that as a to the n as a denominator. So basically, it just makes a reciprocal. Okay, so that's exactly what we're going to do. After you do that, the problem becomes like the other ones that we've done so far today. So really, the only thing that's going to be different when you have a negative exponent is the first step, where we rewrite it as a fraction first. After that, it's just like what we've been doing. So let's begin here with number 4. The first thing I'm going to do is I don't like that negative power. So the first thing I'm going to do is I'm going to rewrite that as a positive power. But if I want to do that, I need to put it in the denominator with 1 in the numerator. In other words, we just make it a reciprocal. Okay? Then the next step after that, everything is pretty much the same. It's just that now we have a 1 on top of it the whole time. So if I were to rewrite that 25 to the 3/2 power as a root, what number would go here? That would be the 2. And here would be the 25. And then finally out here would be the 3. The next thing we're going to do is we're just going to simplify this. Now this is a simple problem. Don't make it harder than it needs to be. We're finding a square root of 25. Now if you want to break it apart and take out pairs, you can, but I think a lot of you guys probably already know that the square root of 25 is just 5, right? But there is something that we do have to make it a little bit harder for, unfortunately. And that's the fact that, remember how we said that if this is a 2, an even number, and you have a positive in here, you actually get 2 answers. So it's going to be +5 and -5. Okay? Now we're going to cube it. So that means we're going to do 5 to the third power, which is 125. 5 times 5 times 5 is 125. So, now, if you raise a positive 5 to the third power, you get a positive 125. But if you raise a negative 5 to the third power, you get a negative 125. Okay? Now, let's be careful there. Just so you guys know, anytime, if this power out here is ever an even power, it doesn't matter if you have positive or negative here, because evens always make negatives go away. So in this case, if you have an even power out here, you'll never have a negative answer. It's always going to be positive. But when you have odds, if you have a plus and a minus, then you're going to get a plus and a minus. If you have a positive, you're just going to get a positive. If you have a negative, you're going to get a negative. But if you have an even power, it's always going to come out positive no matter what. So there's our final answer there, plus and minus 1 over 125. So let's review the steps. Step 1, reciprocal. Step 2, rewrite the denominator in radical form instead of exponential form. Step 3, take the root. Don't forget to check your signs. Step 4, apply the power. Okay? So if we want to write those out, you can. It'd be reciprocal. Oh. Rewrite. Radical. Power. So do the reciprocal, then rewrite it as a radical, then do the radical part and raise it to the power. Okay? 4 steps. Let's apply those steps again to number 5. So first step was to make it a reciprocal. When you do that, the power becomes positive. Notice that this number, the -8, that does not become positive. Just the power does. Okay? So instead of being -1/3, it's a positive. That's the first step, is to write the reciprocal. The next step is to rewrite it. So instead of being in exponential form, we're going to rewrite it in radical form. So 3, -8, and 1. Next, we have a odd root with a negative radicand. When that happens, we're just going to put the negative out here and take the radical as usual. We know we're going to end up with just one negative answer. So the third root of 8. Well, as you guys know, the third root of 8, we've done that a few times. I'll show my work up here. Breaking down 8 is 222. So instead of negative cube root of 8, now we have negative cube root of 222. Group of 3 truths. We're going to take that off, put it out here. And so I'm just left with -2. So that's step 3. So after you rewrite it, you're going to take the root, which I just did, and you end up with -2. And then the fourth step is to apply the power. -2 to the first power is just -2. And so we end up with -1/2. Okay? So reciprocal, rewrite, do the root, apply the power. Let's have you guys try one of them there. Let's have you guys check out numbers 3 and 4. So go ahead and pause the video here and try numbers 3 and 4. See how you do. All right, so here's our solutions. For number 3, we have rewritten this as a reciprocal so that we can have a positive exponent. And then for the next step, we rewrite it. So we have the square root of 36. And I just realized I have a mistake here. This was supposed to be a 1. So change my final answer. Change all those really quick. All right. Anyway, back to where we were. So we rewrote it. Then we take the square root of 36, which is positive and -6, and you raise that to the first power, and you end up with basically plus and minus 1/6. All right, let's take a look at the next one. So the first thing we do for this is we're going to rewrite it as the reciprocal. And I also did 2 steps there. I also rewrote it as a radical. So this is the first 2 steps combined into one. I moved it to the denominator. I put the 3 as the root, the 2 as the power, and the negative 64 there as the radicand. Next, because we have an odd root with a negative radicand, we take the negative out. And then we take the cube root of 64. I showed my work up here. If you break down 64, you should have gotten 6 2s. So you can take out 2 2s because we're looking for groups of 3. And you're just left with negative 4 result. And then we square it. Now if you square a negative, the negative cancels. So this one actually has just one answer, which is 1/16. All right. Let's look at one more type of problem here. All right. So for this one, I'm going to actually add a little number in here. I'm going to put a 4 here. And I want to just change the problem. That way it'll be a little more helpful for you guys. So we have 4x to the 3rd power being raised to the 1/2 power. So what are we going to do with that? All right. Well, first of all, we don't have a negative, right? So we don't have to worry about that. We're just going to go ahead and rewrite it. So it's going to be a root. Here's my root. It's a square root. Here's my radicand, 4x cubed. And then here's my power, which is 1. So I just need to find the square root of 4x cubed here. So let's go ahead and break it down. 4 is 2 times 2. And x is x times x times x. So I could take a 2 out of the radical. I can take an x out of the radical. But I have an x left inside of the radical. And then we have a first power. And as we mentioned before, when you have a power out here, you're going to give a power to everything. So you do 2 to the first power, you do x to the first power, then you're going to do x to the first power in here also. So basically just distribute this power to every term here. And anything to the first power just stays the same. So there's our final answer. 2x square root of x. Here's one for you guys. Go ahead and pause the video here and try number 5. All right, so step 1 is to rewrite it as a radical. We have the radical of our radicand there with the 3 here and the 1 out here. Now, since we're taking an odd root of a negative radicand, we're going to put the negative outside. And then we're going to break apart our radicand into 2 times 2 times 2 with 5 x's. I can take out a 2, and I can take out an x, but that leaves 2 x's left inside. So I've got x squared on the inside. Raising all 3 of these terms to the first power, we're just left with those same first 3 terms there. And so there's our final answer. Okay? And that's how we work with radicals and fraction powers. Next time.